All right, IM3 classes. Today we're talking about transformations of exponential functions and logarithmic functions. We've actually already done the exponential functions part of this. We did this way back at the beginning of the class. It's one of the first things we did when we did transformations of parent functions. We looked at exponential functions with that. Um, so we are not going to do the exponential functions again. We are going to do the log functions this time. So it should be familiar stuff that we are doing here. Let me make sure my board is connected. It should be familiar. A lot of it's going to be the same thing. We really hammered it back at the beginning of the year. In most classes, usually do pretty well on it. So it's going to be old stuff. But let's look at our new parent function that we're going to be doing this. So we're going to be graphing log of x. Remember with the log, this is log base 10. This would be the same with any base. You do the same thing. The transformations all work the same thing. You just the different parent function. We are going to focus on just the common log base 10. So here, the transformation function, actually, before we do that, what we should do is look at a graph of log of x so we can see what's going on with it. So bringing up Desmos here. So let's look at what the function, the log of x looks like. So here, we have log of x. It kind of almost looks like a square root function, except for it goes down into the negatives. You look here, if we zoom out, you can see that this function is never going to cross over the y-axis. It's never going to go into a negative x. So you can't put in a negative value into x. So if you try to do a log of a negative number, it'll spit out error, domain error. If you look here, it crosses the axis at 1, the x-axis at 1. And then if we go all the way over here, the next point that we're going to be using to graph this thing is 10, 1. So it's a slow curve going up. It doesn't get to 2 until all the way over to 100. If you look all the way at the end, we go. So it's a very slow curve. So here goes 100, and then 2, and then it won't get to up to 3 until 1,000. So that is what the curve looks like here. So let's go back and graph this thing by hand. So let's go back to here it is, back to our slides. So let's graph this. So what we're going to do is put in 0 for here. So log is 0. Sorry, when x equals 0, y is equal to the log is 0. That means y is going to be 1. Right? Did I using a calculator? No, it doesn't. Duh. What am I thinking? It's not 1. I'm thinking backwards. You get a domain error, right? Because we looked at the graph. Right? It's not going to cross it's not going to hit the y-axis. So we put in 0, you get the domain error. I'm not sure what I was thinking. But here, so if we do x equals 1, so if we put in log of 1, the log of 1 is 0. So we'll have the point 1, 0. So that's going to be 1, 0 right here. Do it. Oh, good. And then I'm going to do when x equals 10. Oh, it's doing this stupid thing with the board again. You get log of 10. That is equal to 1. So I'm going to put in my point. Actually, I'm going to do a different color so you can see it a little bit better. I'm going to do red. I'm going to put in the point here. So that's 1, 0. And then 10, 1 is up here. And so if you remember, it's a curve. It gets close to 0, never touches it, crosses over here, goes, and it's a slow increase there. So that's what that's going to look like. The transformation function that we're going to look at, it's going to be f of x is equal to a times the log of x minus h plus k. And this should look familiar from what we did a few weeks ago. So if we look at this stuff, this a, right, this is a stretch, if you remember. The a stretches it. If it's negative, right, it will be a flip. If a is negative, it will flip, or a reflection will flip over the x-axis. The next one here, so we have minus h. This is a shift, right? Left and right. And remember, this one is opposite of what we normally do. So if it's minus, you think it'd be shift to the left. No, that's shift to the right. And then plus k, the last one there, the plus k at the end. This is also a shift up and down. And that's exactly as you would think. The generic shape, I don't know, some kind of curve. Follow your heart with that, put in what you want. The domain. So the domain are the x values. So we already looked at the domain. It's never going to touch zero. It's always going to be greater than zero, right? So x is always greater than zero. The y's, it can get any of the y's. You look, it shoots down on the y. It goes all the way to the negative functions, and then it'll slowly increase going up. But it can be all real numbers for the y. So for the y, what we'll do is put in negative infinity. That's a bad infinity symbol. Negative infinity to positive infinity. So it could be all real numbers, and x is just greater than zero. We can also say it goes up to positive infinity, but it's never going to touch zero. All right. So here, let's describe the transformation that's happening. We've done a bunch of these, so just look at the transformation. We'll do a few of them. This is going to be a shift. Since it's inside the parentheses, it's minus. It's opposite what you think, so that's a shift right 4. This one would be a shift left 2. I got to move my screen here. This one is going to be a shift up 3. It's outside the parentheses. It's exactly as you would think. This one's going to be a shift down 6. All right. The 4 in front is going to be a stretch by a factor of 4. And we'll look at how to do those when we graph them. And then let's look at one that covers everything. So down here at number 14, we have a lot going on here. So first there's a negative. So that's going to be a flip or reflection over the x. Then the a value is less than 1. So that's going to be a shrink. When it's less than 1, it shrinks. Minus 5 is to the right 5. And then plus 9 is up 9. Right? So you guys will finish those up. Now we're going to do the opposite. We're going to write the function. So when we're writing the function, what we want to do is make sure we put y is equal to, then you have your log left 3. So that's going to be plus 3 inside the parentheses. And then up 7 is plus 7. So just make sure, right, this is going to be opposite of what you want to do. It's in the parentheses and it's opposite. So like number 2, y is equal, it reflects, so there's a negative in front. It's a log function. Right 9 is going to be minus 9 in the parentheses. And then let's do one that covers almost everything. Let's go down to number 6 because there's fractions and who likes fractions. So here, y is equal to a vertical stretch. That means there's a 4/3 out front. Then log left 5/3. So that's going to be x plus 5/3. And then up 7/12 is going to be plus 7/12. So just go through and all those. And then here is the bulk of it where we are actually graphing the function. What we want to do is similar to what we did with the parent functions, couple months ago, is we are going to graph the parent function. So we need to remember two important points for this. Two important points. So our important points we're going to do are 1, 0, and then 10, 1. These are the important points we need to plot for all these. And those are the ones that we are going to shift around. 1, 0, 10, 1. Right? And then if you want to do a dotted line, and then when I shift, I'm just going to shift here. So this is going to be a shift to the right 4. -4 is opposite. So I'm going to move these points so they're each to the right 4. So 1, 2, 3, 4. All right. And then here's the other thing. You're going to want to move the asymptote. So the x-axis, right, is going to move as well. So I'm going to put another dotted line for the asymptote. So it's like moving the x-axis over, just so we're not crossing over that line, because the horizontal shifts are going to move that asymptote as well. And so we don't have enough space for the 10, but that's okay. Got the asymptote, so it's just going to be, and not a great one. I kind of moved it, but it's kind of hard to do. But you get the idea. Everything is moved over 4. All right. This one here, +3. So again, I'm going to start off by plotting my important points first, so I know what to shift. So there's the 1, 0, 10, 1. And so here, +3 is going to shift everything up 3. So this is going to be a shift up 3. So up 1, 2, 3. And then this one, 1, 2, 3. And then the asymptote doesn't move, right? It's going to stay along that same asymptote, but everything is just shifted up 3. So it's going to look like that. And there we have that one, right? And then, yeah, let's do a stretch, right? So it's going to be a stretch. This one, how the stretches work, if you remember. So we're going to, this is going to be nice because we really only need to worry about one of the points. So it's going to stretch the vertical stretch. I meant to do that as a dotted line. Too late now. It's going to be a solid line. The vertical stretch is going to stretch the points further away from the x-axis. It's going to pull it apart. So if we're looking at it here, it's just this point here. Really, all you need to do is multiply the y-coordinate by 2. All right, so if we take our two important points, so we have the 1, 0, and then the 10, 1, the stretch just multiplies the y's by 2. Here, if we just the y-coordinates, 2 times 2, so that's going to be 0 times 2, you get 1, 0. That point is the same. This one here, you get, it's supposed to be a 1, my bad. 10 times 2 is 2. So this point stays the same. This point goes to 10, 2. So you just need to multiply the y-coordinate by 2. There you go. All right, let's do one more where we're doing everything. Perfect. Number 11. So first thing we're going to do is put in our important points. All right. So we'll dotted. All right. So first thing I'm going to do is that stretch. So I have my important points 0, 1, and then 10, 1. I'm going to multiply just the y's by 2. All right. -2. Sorry. So I'm going to take this, right? And that's why this is, it's going to multiply just the y's by -2. Again, we're lucky. It doesn't change anything there. But this one, it goes 10 to -2. All right, so this stays here. All right, and then it goes down 10 to -2. All right. So here, another little dotted line. It's going to come down this way, but we're not done with stuff. So that's why it's a dotted line. We're still going to move some things around. I'm going to put the final product in green here. So this is going to move each point to the left 3. This is going to move each point down 2. So this point, 1, 2, 3, down 1, 2. So here's this point. This point goes 1, 2, 3, down 1, 2. And then we might as well put in the asymptote again. Let's do the asymptote in dark blue. So the x-axis or the y-axis gets shifted left 3 as well. All right, so here we're not going to cross over this line when we graph these. All right, so that's our little imaginary asymptote where the log does not cross over. And so our final step, connect these dots, so not crossing over our asymptote. And there we go, looks something like that. And that will do it. We'll see you guys next time when we're talking more about properties of law. Stop that.